Welcome to the new video, the language of chemistry. It is a class of class 9 ICSE. In this chapter, we will be discussing about symbol, formula and valency. And the rest part, how the formulas are written, that will be continued in the next class. First of all, what is the meaning of the language of chemistry? It means that chemical reaction takes place inside the test tube, we know it, inside the laboratory, and whenever we explain the reaction, that these mixed with these to get these things, reactants and products we are explaining. So the explanation that when hydrogen combines with oxygen it produces water, that can be written in short that H2 plus O2 is producing H2O. I can say hydrogen combining with oxygen to produce water. So to know the meaning of this kind of sentences, what I have written over there, we need to learn the language by which these are written. So these things are composed of two things, few are symbol and few are formula. First of all, what is symbol? Symbol is the shorthand notation or abbreviation of the name of the elements. So it is the short notation. It is the short notation of what? Of the names of element. So whatever be the name of the element, that can be written in short and that will be represented as their symbol. Such as you know that in your class when the routines are given, they are beside the subject, math, physics, chemistry, the teacher's name are written in short. Suppose some teacher's name is Piyush Kumar, so it is written as PK. My name will be written in the same format, AC. Like this, you know that math will be taken by PK sir, chemistry will be taken by AC, like this. So what is the meaning of AC or PK? These are the short notation of the full name of those particular teacher. Similarly, in this chapter, language of chemistry, whatever be the original name of the element, they have some abbreviation, they are short form. Those short forms we will be saying symbol. So first of all, what is symbol? Symbol is the abbreviation or shorthand notation of the name of the elements. Hope it is clear. Let us take some example together. I am writing few names, C, O, N, B, P, S, etc. Then I am going to CU, NA, FE, SN, HG, AG, AU, I am writing etc. Like this the symbols you have to know. Now the symbols are coming from either from the shorthand notation of their original name in English or from their Latin name. These what are given over there in the first slot, that is the abbreviation of their English name. And from there to there we will be dealing with the Latin names. So Latin names will get preference to say the symbol of these elements. First of all, C. C is the name of carbon. C is for carbon, O for oxygen, N for nitrogen. I am just writing their name. B for boron, P for phosphorus, S for sulfur. Now whenever you are going to Cu, it is copper, COPPER. Na, it is sodium. Fe, it is iron. It is tin. It is mercury, silver, and at last it is gold. Now if I just have a look on these things, see the carbon first letter is C. So from the full name carbon we are taking the first letter, first alphabet C. C is the name of carbon. Similarly for oxygen you see only we have taken the O. For N stands for nitrogen. Boron we have taken B. Phosphorus we have taken P. Sulfur we have taken S. We have only taken the first letter. In the same way, if we take for helium, the name is HELIUM. Beryllium, BERYLIUM. Beryllium. In this way, calcium, CALCIUM. Nickel, NICKEL. There also you see that we have taken the first as well as the second, 2. So these all name what I have written in the first lot and second lot, that is produced, the symbols are made either by taking the first letter or by taking the first letter and another one together. So these are from their original means English name, what is there from there only. The abbreviation is called symbol. Now whenever I am looking for these particular elements, CU, I have written COPP here. So from COPP here we are never getting CU, because in this their U is not there anywhere. These names are coming from their Latin name. So you have to remember the Latin name of this particular element. Cu, copper, the Latin name is cuprum. Na, Latin name is natrium, natrium, sodium. Fe is iron, ferrum. Tin, stannum. Hg, hydrargyrum. Ag, argentum. Au, aurum. Pb, plumbum. W, wolfram. Sb, stevia, etc. Sb is antimony, it is tungsten, it is lead, and so on. So the symbols are written either by taking their original name, the first letter, or first letter and any one letter, either the second one or where we are giving the more pressure, that one also, and abbreviation of their Latin names, this one. You must remember that whenever we are writing the symbol, the first letter must be capital and the second one must be small. If someone is writing NA instead of writing this one, that is correct, that is wrong. Or if anyone is writing NA, that is also wrong. So the format is first one will be capital, next one will be small. Never make mistake over here. Hope it is clear. So like this, you will write this one, copy in your copy and memorize this one. These are the symbol of different element. Now symbol have some significance also. For example, if I just rub all the other things leaving only Cu here. So what does this Cu means? Cu means it is one atom of copper. One atom of copper. Copper is an element. It represents one particular fixed mass of copper, which will be their atomic mass, relative atomic mass of copper. So like this information we are getting from the symbol. Leaving the symbol, if we go to formula, then few formula you are already known to you from the previous classes, smaller classes, H2O, CH4, CO2, O2, N2, etc. If I ask you what is this, you know that H2O means water, CH4 means methane, CO2 is carbon dioxide, O2 is oxygen, N2 is nitrogen, and so on. You already know that NaCl is sodium chloride, MgCl2 is magnesium chloride, FeCl2 and FeCl3, these are ferric chloride, etc. Ferrous and ferric chloride, etc. So what are these? Water is a compound, methane is a compound, carbon dioxide is a compound, like that oxygen, nitrogen, all these are a molecule of the element. So the molecule's name. So the molecule's name, molecule of what? Molecule of element can be and molecule of compound can be, whatever it is. So the molecule of an element or molecule of a compound, it is having a name, and that name when represented in this kind of notation, that abbreviation is called formula. So what is formula? Formula is the abbreviation of the original name of the element or compound. Their means molecule's name, that is called a formula. Now after coming to this part, one tricky question many times comes over here and students get confused over there, such as you are given a question N, N2, 2N, 2N2, and you are asking that what is the difference between these four, or what does they represent. First of all, whenever I am written over here N, it is one atom of nitrogen. One atom of nitrogen. Nitrogen is an element. N2, it is one molecule. It is one molecule of nitrogen. That is also element. 2N, two atoms of the element. And it is two molecule of the element, nitrogen. Hope it is clear. This kind of tricky questions many times asked in your exams, and you are making mistake of writing the formula. Sometimes you are writing like this cursive handwriting. It is Al, aluminium. Boron you are writing like this. This will not be accepted. You simple write aluminium is Al, boron is B. This format. Never use cursive while writing the symbol of different elements. Now the question is coming, what is valency and why should we learn it? Just in the previous what was written over there, I have written FeCl2 and FeCl3 both. So if I ask you that why number of chlorine here it is 2 and here it is 3, what is the reason? The answer is coming that it is the reason. The answer is present in the term valency. If we know what is valency, then we will be able to answer why there is 2 and why there is 3. So first of all, let us learn what is valency. Valency is the combining capacity of an element. You know about that in the previous class. Similarly, the combining capacity of an element with hydrogen, it was also told later on. With respect to oxygen also valency was defined. But we will not look at all these things. We will look simply on the things that valency is the number of electrons either lost or gained or shared by an atom. By an atom. So once more I am telling what is valency. Valency is the number of electron which is lost, which is gained, or which is ever been shared by an atom. Now the question is that why should an atom will lose or gain or share the electron? The answer you already know that it is due to the stability of the atom. Here I am just reminding one thing about octet rule and two-plate rule. That when you have learned atomic number, the number of proton, for example sodium, what is the atomic number? 11. Chlorine, what is the atomic number? 17. That means in sodium atom there are 11 electrons are present. In chlorine there are 17 electrons which are present. Now these electrons 11 and 17 they are arranged in this, that the K cell contain 2 electron, L cell contain 8 electron and M cell contain 1 electron. They are also 2, 8 and 7. We already knew that the last cell, here the M cell and here it is also M cell. The last cell is called valence cell and number of electrons in the valence cell is called valency. So what is the valency of sodium? Valence cell there are only 1 electron. Sodium is monovalent. And what is for chlorine? It is having 7 electron. So its valency is also 1. How to calculate that one? If the valence electrons are either 1 or 2 or 3, those atoms try to lose that electron and they produce cation, positively charged ions. How many number of electrons they have loosened to produce the ion? That number is called valency. In this case, sodium is unstable because it is having only 1 electron in the last cell. So what will happen? It will lose the electron. How many electrons sodium is losing? Only 1. That means sodium's valency is 1. On the other hand, chlorine, there are 7 electrons. It will become stable. It is having 8 electrons in the outermost shell as per octet rule. So if we give 1 electron from somebody else, it will become 8. Octet will be completed. So chlorine will accept 1 more electron. For this purpose, its valency also 1. So this is the case what I have told, lost or gained. Sometimes they can also share. Loss and gain are the case of ionic compound and sharing is the case of covalent compound. Now these things, how these things are coming, what is atomic number, what is mass number, how electronic configurations are done, how the valencies are calculated, all these things in some other complete video I will discuss again. We will not look at these things. We will simply memorize the valency because you know that in this way you can calculate the valency of element, but for the radical means group of atom having a charge. We cannot calculate in this particular way. So now we have to remember the valency of cation and valency of anion. Valency 1, this is for cation, this side I will write and that side I will write for the anions. Valency 1, what are there? These are called monovalent. Hydrogen, I can write H plus. because it is forming positive ion, so I can write H plus. Hydrogen, except hydrogen there will be sodium, there will be potassium. These all are monovalent. Sodium, potassium are also monovalent. Leaving this fluorine also non-metal, so I will not write in this part. I will stop here only. Hydrogen, sodium, potassium, these are monovalent. Now valency 2, what are the elements? That is having divalent elements are what? Divalent elements are calcium Ca plus 2, magnesium Mg plus 2, zinc Zn plus 2, like this, barium Ba plus 2. These are the common element having the valency 2. They are having valency 1. One more is there, NH4 plus ammonium. Now see, there are 5 elements carrying only one positive charge, so it is a radical. These are also only this is from the radical. Valency is 1, all of them. Their valency is 2. Valency 3, what there are? Valency 3, the elements is aluminum 3 plus. One is most common. Which are needed, I am writing that only. No need to remember everything. Valency 4, carbon is having valency 4, silicon is also having valency 4. I am not writing any charge over there because plus 4 charge is unstable totally, so doesn't form. Then few elements are there that shows variable valency. Variable valency. What they are? Remember this one, iron. Iron is having valency 2 and valency 3. Copper, valency 1, valency 2. Then there are tin, valency 2 and 4. Lead also 2 and 4, etc. There are many more, but we do not remember all these things togetherly. Initially start with all this. There are at least 15 maybe. So start with this 14, 15. Then slowly whenever we learn a new thing, you will just add over there with the lot. If you get anyone of valency 3, you write there. Anyone with having variable valency, you write, put there. Then remember that one. Now there one more thing. These are that laser one. 2, they are 1, they are 2. This laser one, they are called Us. O-U-S. Us. And the other one, that means which are having the larger. Here 3, 4, 2 and 4. That is called Ic compound. So iron with 2 valency, ferrous. Iron with 3 valency, ferric. Copper with 1 valency, Q plus. Copper 2, cupric. Lead 2, plumbous. Lead 4, plumbic. Remember this one. Now remember for the anion, chart of the anion, also very important. Like this you remember chloride, bromide, oxide, O2, 2 minus is peroxide, then O2, OH minus, remember, OH minus is hydroxide, F minus is fluoride, N3 minus nitride, S2 minus sulfide. These are monovalent, as I have written, mono and di both are written over there, but in this way you can remember them easily. Leaving this for, I can say NO3 1 minus and NO2 1 minus. That is from one lot. Then SO4 2 minus and SO3 2 minus, forming one lot. PO4 3 minus and PO3 3 minus, also forming another lot. In this way, these are nitrate, nitrite, sulfate, sulfite, phosphate, phosphite. One tricky things is there. Once you remember them, which one is starting with 8, that is having 1 oxygen more. Nitrate 3 oxygen, nitrite 2 oxygen, phosphate 4 oxygen, phosphite 3 oxygen, sulfate 4, sulfite 3. So like this you have to remember these charts. Side by side, few other elements are there such as arsenite, bromide, then dichromate Cr2O7 2 minus, Cr2O7 2 minus, manganate MnO4 minus, Few like this you will get. Remember them. Carbonate is CO3 2 minus. Now one more thing I will just say over here. Whenever you will put one hydrogen in front of them, then the term will be bi, such as this is carbonate. If I put HCO3, so one charge will be less, 2 minus will become 1 minus. This name is coming bicarbonate. Similarly, if I write HSO4 1 minus, it is bisulfate. HSO3 1 minus, it is bisulfite. Okay. So in this way, the cations and anions chart you have to memorize. Remember. Now you will ask me that today in the video from the first time just saying memorize. Why should you memorize this one? Because once you give your effort to memorize all these things for the first time, in future you will not have to face any trouble to write the formula, to write the balancing, how to balance them, how to write any kind of chemical equation, because these things all are interrelated. You cannot ignore them. Start slowly. First you memorize the symbol, very easy, carbon C. Like this what I have written the chart over there, you copy all this in your own copy and you try to tell with me, say with me. Symbol is over. After that what should you learn? After that you must learn this valency. This is very important. Once you learn this one, next day I will discuss that how to write the formula. So today I have discussed symbol, what is it, what is formula, what is valency. Our next class we will learn how to write formula, and whenever we will learn or we will go to this part, I expect that before going over there, these things will be memorized by you. Okay, so let us prepare these things and again we will join in the next classes. Bye, get ready.